Okay. Here we go. So, I will be in this video. We're gonna make I think we're gonna make a Scorched Earth clone, or at least get started on one. We'll see how far we get. If you guys haven't seen Scorched Earth, it's kind of like, I don't know. My dad actually had it back on our old computer growing up when I was a really young kid, and pretty much you it's this really old game. You got these tanks that kind of sit on a weird generated hillscape, and they just kind of shoot weapons at each other. So you can see he's adjusting his power and his angle. It's very much like Worms. I'd say this is a predecessor to Worms. And they just kind of shoot each other and they kill the ground, and then he hits them and explodes, and then you get a little bit of money. And then before the next round, you can buy different weapons. And different weapons can do different things. So these little baby missiles, they just kind of explode on impact. You can get funky bombs, which when they hit the zenith of their I think that's how they work. Some of them, they'll hit the zenith of their approach and then explode into a bunch of different bombs. Some of them will hit and then explode into different bombs. Some of them are napalm, and they'll hit the mountain and then they'll have a liquid flow down. Some of them will actually bury your opponent in dirt, stuff like that. So anyway, I just thought it's kind of a fun. It's a very fun game back in the day. Here you can see they're just doing. I think they just dumped a bitmap in as different pixels. But in general, it's pretty simple. You just got some terrain, and I think we can probably have some fun doing direct pixel comparison rather than normally I would keep all my game objects in memory as objects, but I think here we can maybe even just keep track of every pixel on the screen, and maybe we'll see if we can avoid redrawing the screen in between. Something like that. So let's get started. So first, I think we probably want to just generate a random level somehow. So I'm going to, let's make a new Pico 8 game. So let's just save, or let's reboot, and we'll save Scorched. All right, and then I'll crack open my editor here. We'll get this going. So here, let's make this just a little bigger. So normally I have just a Pico kind of preset here, so we can do this. Now, I'm not sure whether we're gonna want this in the long term. I'm not exactly sure how we're gonna keep track of all of the Earth that's on screen. I think it'd be a fun challenge to keep track of it pixel by pixel, but that also kind of seems hard if we're gonna be drawing other things on the screen. So not exactly sure what we're gonna do there. Let's just start by trying to draw a randomly generated level or something like that. So I don't know, let's add to our draw function here, and we're just gonna have draw landscape, and we'll make a function, draw landscape. Cool. And I don't know, if we really wanted to do this right, we would probably draw some Perlin noise, which is it's commonly used in game development, where you're doing randomly generated smooth terrain and you need to do it on a GPU. We don't have really any of those requirements, but it is a good way to have a smooth sort of terrain. But for now, maybe we can just do like sine waves, like additive sine waves or something like that just kind of all build on each other. So let's say we're going to draw like a horizontal terrain. So we're going to say for an x value of 0 through 127, should be all of our pixels. Then we need to calculate what our y value is at that point. And to start, we'll just do like literally a sine wave. So I guess we'll take the sine of x, and in this case, it's going to be like, if we just did x, it's always going to be a whole number, so it's always going to be the same value. So for instance, if we do like p set xy with like, I think that's red. Let's see what happens if we try and run that. Yep, so it just literally does a straight line right across the top of the screen. Not so great. So what we probably want to do is do x is, so let's do, I don't know, we'll call this like position or something. Position is x divided by 127, which should get us exactly one sine wave cycle as we move across the screen. And then we'll do the sine wave of the position. We'll see what happens then. So yeah, it's going off the top of the screen, so we're gonna need to, let's say, move it down a little bit. So y is gonna be this plus like 60. Okay, and then we can see it looks like it's doing something, but clearly it's moving between 0 and 1 and -1. So we need to scale it up a little bit. So we're gonna just multiply that by like 10. Okay, so there's a nice little sine wave. So not like a completely random hill, but what we can do is we can add a couple of those sine waves together to get a little bit more randomness. And they'll just kind of interfere with each other. So I'm gonna pull out a function for like a sine wave, which takes, so we have like different parameters here. So this is the offset, here's the position, here's the, I guess, amplitude. And then I think we can scale this to adjust the period. So if we make this function here, we can leave the offset out. I'm sure we can figure out how to use that. And then we'll take the position and the amplitude here. And then we need to scale the position by our period. So period can be this thing, which is just kind of like how much distance it needs to cover, like how quickly it cycles. So let's see if this actually works how we expect it to. Yep. So rather than do this, we're going to just do 60 plus the sine wave of the position. And then for the period, let's try a period of 2. I don't know whether we need like 2 or 0.5 to get what I want, but we'll see. And then the amplitude, let's do 10 like we were doing before. If we refresh, then we crash. Attempted unexpected symbol near star. Am I not passing enough arguments? For one, I should probably return that. Yep, and that's better. Okay, so we can see like upping the period makes it a little bit more wavy. And then we can, for instance, add another sine wave to this. We'll use the same position, but we'll change the period so that it kind of looks different. So we'll do a period of like 0.7 or 8. And then we'll do like a similar amplitude, and we'll just see what that looks like. Maybe it'll be interesting, maybe not. Yeah, so look, now we've got like this kind of bigger slant to our topography, and then like some smaller wavy ones. And if we want, we could do like even smaller, but it starts to look funny if you do too many of those. So like here, let's just do it for the sake of it. We'll probably get rid of it after. But if we do the same thing and then we crank the period like way up, like 5, and then let's just do 5 and 5, this should like add a bunch of small waves. Yeah, that's not too bad actually. I like that. There, so now we have like a level generator. Now it's not random, it's always the same. But we can, of course, introduce randomness into it. So we would probably need to like initialize our randomness. So it's not random like literally every time the screen draws. So let's just do a seed in here, and let's just say we have a random seed. And then we can use that random seed to multiply something by something. We could do like some sort of modulus, or we could just multiply the position by like 100 times the seed. I don't know what this is gonna do. Who knows? Let's find out. This is how we do game dev. There might even, there's probably a more elegant way to do this sort of thing, but I'm no expert at this. So that did something. It's definitely randomizing. It's kind of weird. Why is it doing that? The seed should only change once. So maybe this is too high. What happens if we do this? Oh, I probably want position plus 100 times the seed. That would make more sense. So this is going to offset the position. So it's not going to scale it. I think the one that we were doing before was scaling it. And this is going to just offset it. So it'll hit at a different spot in the curve. Yeah. So there we go. So that's a little better. So now they're all kind of like similar landscapes, but like, I don't know. I think that's kind of interesting. So we would move that seed into like a level generation or something at some point. But like that's not a whole lot of code or math to do this. Now we probably want to fill in all of the earth underneath like the top layer. So let's do a I guess we have to probably p-set everything underneath it. Hopefully, I mean, if we're only doing it once per frame and we're just kind of filling in everything, it should be fast enough. We might have performance problems at some point, but we'll figure that out when we get there. So let's do we could have some fun with signed distance fields and stuff on this too, so we could like make it different colors as you go down. We'll try that once we get this working. Okay, so let's say now that we have our X positions and our Y position, let's say we go all the way from the bottom of the screen, which is 127, up to the Y position by moving by -1. Then we do, and this is gonna be, well, so this is the topography, I guess. I don't know, probably a better word. I'm a programmer. We're not good at naming things. And then for the topography, we go through there, and this is Y. So Y is gonna go from the bottom of the screen to the topography. I mean, we could do it either way, right? I guess literally we could just go this way. That's probably easier, 127. And we don't need this extra term here. Saving those tokens. And then we just fill in every one of those pixels. That should be the same, right? Yep, there we go. So now every time we refresh, okay, we're filling in the whole level. Let's make that green. There we go. So we could randomize the color too, actually. That'd be kind of cool. Let's do that. So I think I'm just gonna make an array of like landscape colors, and we can have like I have the screenshot of the thing from Reddit here, just because the Pico 8 subreddit has all the colors that you need. So moss would be good. Probably like 1, 2, 3, 4. 5 is kind of boring. Let's do 1 through 4 and 8 through 15. So pretty much all of them. Honestly, let's just do all of them. Okay, we don't need to worry about that. So the color here is going to be a random value between 0 and 16. And I think that's exclusive on the top end, so we should just be able to do the floor of that. And that should round it down. Is it floor? There should be fleur. It's fleur. Syntax highlighting for the win. And then we can just color it that way. So now we should randomly generate the color of our terrain as pretty much any of the colors that Pico 8 has, which is great. We could also like randomly, oh, we probably don't want black in there. That's not a good color. And then we can, maybe we'll set the sky to be an interesting color too. Which we can easily do by just doing a rect fill of 0, 0, 127 to 127. I think I have that backwards. I think I need 0, 127, 0, 127, and then this can be blue. So maybe I will bring back like the landscape colors. And I'm British. No, I'm Canadian. Same thing. 1, 2, 3. And then this way we can just like pick and choose our colors as we want. 10, 11, 12, 13, 14, 15. Okay. And then we don't want 0 in there. And we don't want 12 because it's going to be our sky color. So then we can say, let's just make a function for like choose. And it'll choose from a list because sometimes it's annoying. So we'll pick a random value, rand, from the length of the list. Is that how you do length? Let's find out. Length of 1, 2, should be 2. Call global length. Oh, it's like the hash symbol. That's how that works. I always forget. Okay, so it's the hash, so the length of this thing. You've got a couple people watching. You guys program Pico 8 too, or are you just checking it out? Let's get the, so n is just going to be a random number between 0 and the length of the list, which means if we take the ceiling of it, we should be able to index into the list with that. Now, of course, this is going to be, is it seal? Okay, I don't know. Got to check the wiki. Let's pull up the wiki. Let's try, oops, Pico 8 math. All right, we'll keep this handy. So I know there's like a floor thing, but where's the ceiling value? Memory, API reference, it's probably in here. It'll be next to floor. Is there really no ceiling? No? What? Oh, yeah, there it is. Okay. Well, I wonder if it's just, was this added at some point? That's interesting. I wonder why that doesn't exist in my highlighting. Anyway, not important. So now we have this like random choose something from the list. No problem. So now we can randomly choose a color. Choose from landscape colors, and that should randomly pick something. So let's refresh, and let's do this, and let's do run. It's saying unexpected symbol, and that's because I forget that Lua uses curlies. There we go. Refresh, 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 refresh. Great. Okay, so now this rect fill. Why is this not working? Did I get the parameters for that wrong? It's always good to have the Pico 8 wiki while you're exploring. X0, Y0, X1, Y1, X0 Yeah, okay. I actually did have it right before. What do you know? So now we should get a nice blue sky on our weird pink hills. Okay, sweet. Now I probably want this land a little bit lower so we actually have room to play the game. So let's bump this up to 90. There we go. And presumably we'll never like underfill. Oh, it looks like I'm missing something. Does it need to be, does this loop need to go to 120? No, not that one. This one needs to go to 128. That's weird. Why would that be the case? Well, it seems to fix it though, so I guess we'll go with that. Cool. Okay, so we're in good shape. Let's save there. And then now we need, what should we do next? I'd like to draw a little tank character, and I'd like to have him like be able to shoot something, of course. So yeah, I don't know. Let's try something. I think we'll probably have the tank as an object for now, and they'll have a position, and they can start. Well, so they're gonna want to start somewhere on the curve. So I wonder if we have to set up our seed, yeah, and all of this beforehand. So this will probably need to be a function that computes our topography at the beginning so that we can keep reusing the same topography. And we'll make edits to that topography as we go. So I'm just gonna call it topography, because why not? And this can just be top. Okay. So, and it helps that it's literally the top in that case. So we're gonna do a function for the topography that it'll take in an X and it'll give us the Y position. So I think that literally is just this function here. So we'll just return that. And then we can just do the topography of X. And hopefully that did not break our game. Let's see. It did not. So now when we draw our tank, let's say to start off with, we really only need to know the X position, because we can compute the Y position of it. It's got to be, at least to start with, it's got to be on top of the hill. We'll probably change that later. But so let's draw, and we'll like add a draw function to our tank here. So tank draw function, tank draw, can say that we are going to get the topography at self X, and we're gonna draw something there. So I don't know if I really want to do a sprite. I can probably, we're gonna be drawing like a line for kind of the cannon. That's how the old game works. It just has like a little cannon shoots out the top. And we're gonna be using like, you have to compute like angles and stuff because we're gonna be moving that around. So sprites aren't gonna do it for us. We're gonna have to do like pixel perfect drawing here. So I'm gonna do this. I'm gonna say we got our Y, and then we can draw a rect fill at how big is a tank? 6 pixels. Tanks are 6 pixels, right? 8 pixels maybe. Let's do an 8 pixel tank. Maybe that's too big. We'll find out. So we can do, we'll start at self.x minus 4. We'll start at Y minus 2 maybe, and then we'll go to self.x plus 4 and Y and see what that looks like. Now, we're gonna have to set aside at least one color for our tank that's not one of these, we don't want the tank to be the exact same color as the background. That would be bad. So let's just pick one. What color do we want our tank to be? Yellow is probably a good color for a tank. We could be white. Because you probably don't want, well, I guess you could have white ground. It'd be like, I don't know, Snowy Mountain or something. We can do green. Well, we're gonna have probably green ground, but we have moss for that. So let's do lemon. We're gonna make our tank be yellow. We could also randomly generate the tank color, but we'll get to that. So, okay. So this is gonna be the tank color, which is going to be 10. Yeah. For now, we'll start off with him always at 40. Or we can just do this and say you're going to be somewhere in between like 100 and what, 10 plus 10. We don't want them right at the edge, but like, okay. So now this is probably going to do nothing because I'm not calling draw tank. Yeah. Draw the tank on top of the landscape. I guess this is tank :draw. Okay, we got our tank. It's a little rectangle. That is not working. Okay, he's probably what, like 4 pixels too high. What is happening here? Oh, I wonder if why is the Y position all screwed up? Where am I setting the seed? Is it before I set the? No, that seems fine. Okay, so the seed is getting set there. X is random, but it only gets initialized in the init function. We're gonna fill from, okay, topography, self.x. Is this random? No, it's not random, otherwise it would be jumping all over the screen. Oh, but we're computing the position. Where's the position? Oh, that's weird. What the? That needs to go there. So I wonder if X actually shouldn't even be an X value. Well, it would have to be, so this is probably fine. I'm surprised it didn't give me an error. Maybe I need to be using more local declarations. It's probably smart, right? Local X, local Y. We won't run into those errors in the future. If you're gonna use a global, then make sure you mean to use a global. How about that? Is that better? Oops, what happened? Attempt to call a string value. Local X. Can you not put local inside one of these? Maybe not. Try again. Yep. Okay, our tank is now, that was a weird bug. Our tank is now mostly sitting on where it's supposed to be. It's a little chunky. Let's make the tank a little smaller. So we're gonna say like, I'm gonna chop 2 pixels off either end, and we'll make it just 1 pixel tall. How does that look? Yeah, beautiful tank, right? It's a little rectangle dude. But that's all we need. And then we'll draw a, let's say that the tank has like an aiming angle or something. So we'll have an angle, and we'll start with it pointing straight up, which I think in traditional trig or whatever, normally it would be like, I don't know, related to pi or something, but Pico 8 is kind of nice in that it does all of its trig like between 0 and 1. I think that was a really nice design choice, honestly, so thanks for that. And then what we need to do is we can convert this into an X component and a Y component. So this is just an angle between 0 and 1, where 1 is 360 degrees. So 0, I think, would be facing directly to the right, and so then 1/4 turn from that is hopefully pointing straight up. We'll see. And then we want to draw a line. So this will be like our cannon. It's like pointing in that direction. So we'll start at the tank's like middle, which I think I drew with self.x comma y. And then here, let's just make this consistent. Local x equals self.x. Okay. Then we can get rid of this. All right. So now we have the base of the tank. Actually, you know what? Let's change these. So this will be y, and this will be y plus 1. So then now, like, the center, like, my coordinates are right at the top middle of the tank, which hopefully looks right. So we'll draw a line from, let's just see what happens if we draw a line straight up first. So it should be same x and then like y. Let's draw it like 3 pixels tall. in the same color, the tank color yellow. So, okay. Yep, that looks about how I'd expect. Let's make it just, you know, just a little longer. There you go. Perfect. Okay. Still looks a little silly, but you get what you pay for. Okay, and then we want to move it. So we're going to start in the same position no matter what, but the X and the Y position are going to move based on the angle of our cannon, I guess. And then we'll rig that up to like move with buttons and stuff. So let's rig up. So X is going to be offset by the cosine of the angle, and I think I'm gonna have to like multiply that probably by the length of this thing, I think. So let's pull out some constants. So we're just gonna say that the, I don't know, cannon length is 4. So this should be X times 4, which is the cannon length. And this one is going to be not minus 4, but normal Y times, no, we can't multiply it. It has to be added. Yeah, okay, like I'm doing there. Okay, and then this one's sine. It doesn't really matter which one you use, whether like sine or cos, so long as you use the opposite. So I think X is typically cosine and Y is sine. I don't know, maybe it's backwards. It doesn't really matter. You'll just have to offset your angle by a bit. So we'll figure out whether it worked or not in just like 2 seconds here. I think this works. I'm probably not going to explain the math behind all of this trig right now. If you want to learn game design, like trig is super handy. So it's pointing directly to the right. That's interesting. Let's rig up our buttons so we can actually change the tank angle. So in our update function, we should be able to say button. If we're holding button something, this is where I always need to go back to the wiki here. Button. The button number. So button 0 is left and button 1 is right. So button 0, button 1. So if button 0, then tank dot angle minus equal, and we'll just move it by like a very, very small amount so you have good control over it. And alternatively, if we want to move to the right, we move to the right. I might have that backwards. I usually just do guess and test because who knows. All right, so can I move it? It's not moving. I have made some grave error. What is going on? Tank dot angle. If button 0, it's in the update function. Did I name the update function or anything? I think so. In the draw function, drawing the tank. It's the angle does go between 0 and 1. Multiplying it, starting at the same spot, adding that times the cannon length. That all looks right. What's going on? Let's see. So, did I refresh this properly? Yeah, I did. Okay, must be something with our button logic here. So in our update function, yeah, I mean, there's not much to it. Okay, well, let's print out the, let's do some fancy debugging where we just print out the tank dot angle. And let's see if we can tell what's going on here. It is moving the tank angle. Okay. It is not, however, moving the actual line here. So why is that? So if we take the cos of the angle, we multiply it by the cannon length. I'm using X and Y properly here. I think so. Filling in the rectangle. Let's increase this by a bunch so that we can actually see if anything is moving. And it's definitely not. Not moving at all. Where is this X and Y coming from? So the X never changes, the Y never changes. It's only the angle, and the angle is not the tank angle, so that's why it's like passing in nil here or something. I don't know why that's... Why is that not erroring? That should be erroring. That's really weird. Oh well. Tank dot angle. That's an annoyance. Okay, so now this should work. Now we have our comically large tank that can shoot in any direction. All right. Wonderful. Okay, let's pull that back a little bit here. And as always, I got my directions backwards, so we're just going to swap those two. And now I can hit to the right, and I can hit to the left. You can't really... Maybe it should be like a little longer so that you can actually tell which direction it's pointing. We could add like a little... Yeah, okay, that's almost too ridiculous. So maybe we add like a little helper so that you can see which way you're aiming. But we'll worry about that once we can actually shoot something. So we've got our little cannon here. Cool. Okay, let's get it shooting something. That'll be fun. So, how's that going to work? Let's do... We need to be able to like make a bullet, and then I'll probably have to look up like the gravity equation or something like that. I don't know. We'll have to be able to set... Okay, let's make it so we can set the... So the tank will have like a power as well. So we have an angle and a power. That's how the original game works. For those just tuning in, we're making a Scorched Earth clone. So I really did love that game back in the day. Had a lot of fun with it. Let's say we start off with a power of like 1. And then when we hit the A button or whatever, we will shoot. So that we can check with button P. Let's see here. Of, I don't know the difference, so we'll just do 4. 1, 2, 3, 4. So the difference between button and button P checks whether you just press the button, or is just normal button just checks whether that button is currently pressed. And we only want to do this once. So we'll do tank fire, I guess. And when we fire the tank, I guess we'll probably have to keep track of all of our bullets. We'll expand this to like, we'll probably add different bullet types and stuff way later on. All right. So how do we draw a bullet? Easy, we can just do a single pixel. Let's make like a new bullet function. And this will add to bullets a new bullet. And the bullet is just an object. It's going to have an X and a Y and probably a V, which is going to be the velocity. And I suppose it needs like, I don't know exactly how this is going to work. We either need to program in like the arc that it's going to take before it even launches. I think that would probably be the easiest. So like maybe we do like an F. So the F is going to be like the function that it launches on. I don't know. We'll see. Okay, so we're definitely going to need an X and a Y. So that's the starting position of our bullet. Then we need an angle and a power. I guess speed would be probably more accurate. And then we will use that to construct a function which we can then follow here. So I think this is really just going to be like the equation of a parabola. And I mean, we could like look up whatever the gravitational one is, but video games don't have to be realistic to be fun. So what normally it'd be like x squared, I guess, is like the most basic parabola, and we just flip it upside down. So that's pretty easy, I guess. And then we'll have to use y and x to offset. So the f is going to be, okay, we'll make a little function inside here. I think you can do this in Lua. I'm not super familiar with Lua, but this will be a function which takes in an x, and so this is going to be the start x. We need to know that, and we need to know the start y. But this is going to be like the current x. So we're going to do x plus the start x, because we have to offset it. Squared. Oh, we don't, do we need the, yeah, okay. I don't know if we can do squared in, can we do like POW or something? There's probably POW. No? Is there no math thing for this API reference maybe? We can always just multiply it by itself, but it's nice to have. Where's the math section? Let's see if we got anything in here. We got square root. That would imply that we have a power function, but I don't think we do. We can write one. It's not a big deal. Let's write one because who knows? We might need more sorts of things. So pow of base to the exponent is just going to be the base. So if the exponent is, I'm not going to make this like, I don't think I'm going to handle negatives or whatever. So let's just say if it's less than equal to 0, then return 1. This is not correct, but I'm kind of fine with that. And then, well, I don't know. It's been a long time since I took high school math. Otherwise, we'll do base times the exponent, and then multiply that by the power of the base times the exponent minus 1. That is a really stupid implementation. I'm sure I'm missing something much easier than that, but who's counting? This isn't a job interview. So, okay, so we want that x by that, and then we want to take that to the second power. I'm going to square it. And that should get us a parabola of some sort. I don't know what that's going to look like. We could draw it, though. And we need to get the start y in there. So I think then we add the start y after we've computed that. Yeah. Pretty sure that's something. So then we can set this as the function for our thingamabob. The velocity, we'll just have this be, yeah, v equals power start. We're going to start the bullet at an x of start x and a y of start y. We don't need the y because we can compute it. So if we punch 0, yeah, okay. Then we add the bullet. So then let's draw all the bullets so that we can actually see whether we're doing this right. We'll draw the bullets above everything else. So let's say for b in all bullets do end, and let's say bullet draw. And then when we create a new bullet, we'll just add a draw function to it here. Ooh, I'm gonna sneeze. All right. function bullet draw, and so I guess we also need to somehow keep track of like which position along the X. No, that should be handled here. Okay. So for the bullet, we're gonna punch in self.x into self.f. That will get us the y, and then we just p-set x, y to whatever color we want our bullets to be. So let's pick a bullet color. Pink is probably good. Wine would be okay. Storm is fine. Probably want something bright. I would usually go with red. Let's go with red. So we're gonna pull red out of our possible landscape colors, so we don't have to worry about it. And then we're gonna draw our bullets in red. Okay. Now, we don't actually have an X. This will be self.x. Okay, I think we have this mostly figured out. So now when we hit tank.fire, that's just going to create a new bullet. All right. At the tank's X and the tank's Y with, oh, and I can't just get the Y, I have to do, maybe this is a stupid idea. What is it, topography or whatever? Topography of the X. I should probably just have that be a function on the tank, but topography of the X. Okay, yeah, that's annoying, but that does work. Okay. So a new bullet starting there, and we'll just currently put in the tank.angle, which we are not at all using for our parabola. We'll have to have the angle represent, I think, the rotation of the parabola. Nope, that doesn't work because then gravity is going to go sideways. That's weird. I guess we could have it pick the initial position on a parabola. I don't know how you'd solve for that. Maybe it would be easier to just literally use like a gravity equation. That's probably true. Nonetheless, we'll just try firing in a parabola for now. Then we'll pass power. So tank.power, right? Does the tank have power? I think we said that, yeah. All right, so now we will inevitably crash for some reason. I don't know which reason it's gonna be. No. Did it do anything? No. I'm trying to create some bullets. I don't think it's doing anything. So when I hit this button, it should fire the tank bullet. It should create a new bullet. Oh, we never call draw on the bullets, do we? Oh yeah, we do. Okay. Oh, but we do it before we draw the tank, which is probably why it's not showing up. Okay, so now I can see it changed the the color of the text, but it didn't actually accomplish anything. Oh, why am I drawing the tank twice? That's weird. So we are drawing at least one bullet. It's just not really showing up. So let's actually see where the bullet would end up. So when we draw the bullet here, he said that I'm just going to print out the X and the Y, I guess. Self.x, self.y, and bullet. I don't think I can do that, can I? No. Can I? Yeah, no, that's not how you do that. I want instead to print out these separately, I guess. Oh, x is nil. Why is self.x nil? That's bizarre, because we're setting it to start x. Am I passing in a start x of nil? Tank.x, is tank.x nil? No, tank.x is set. Tank should be self here. This should be self, but that shouldn't really affect this, I don't think. Self. So we're setting start x of the bullet. Oh, there is no self.y. Whoops. That's a problem. It should just be y. Hello. Okay. So it picked some values there. They're very interesting values. So it picked an x of 44, which is probably correct, and a y value of 15,710. So I'm guessing our parabola is not working as expected here. Yeah, it's pretty funny. Why would it do that? So we're gonna do this. Oh, x should be relative to where it started. So it actually, I think, should be minus start.x. Not plus. Let's see what happens then. Still probably, yeah, it's still off by a little. Oh no, there it is. Look at that. So we can see our little red dot now. So we're starting it at the beginning of the parabola. Funny how that works. And then over time, we need to move it along the parabola. So I think in update, maybe, let's see, for all bullets in our bullets, do bullet.x plus equals 1. This is going to completely ignore which direction we're supposed to be moving, but we're going to try it. Yeah, okay. So if we want to shoot it to the left, here, let's see. Oh, still going straight down. Oh, and that's because our y values are already inverted, and we forgot to adjust for that. So the start, we're just gonna invert the y values, I guess. Let's see. Oh yeah, okay. So we shot it up. I don't know if it's ever coming. Oh yeah, it's coming back down. Oh, I wonder if we're getting overflow. Why is it the y value is cycling? I think we overflowed. So how do we scale back our parabola, right? I think we have to like multiply x by something. Pretty sure. So let's try this. We could probably let's pull up Wolfram Alpha. It's been way too long since I did any math. So let's say x times, well, let's do x squared first, I guess. X squared parabola. There you go. Look at that. It's beautiful. So we're hitting like 1.4 at about, well, like we're around there. Well, 1 should be probably 1, right? But if we multiply this by 10, what do we get then? Should widen it. Oh no, it did the opposite. Okay, let's try dividing. Yeah, that makes more sense. Okay. So let's divide this by like 100 or something. I don't know why. I probably shouldn't be investing more time in our completely broken parabola method, but I just want to get some. Okay, I made it a little too small. That's why we do game dev. Whee! I should probably get it moving the right direction too. Okay, so let's set v. So v is going to be the power, but we want the power to be multiplied by the sine of the, is it like the cos of the angle or something? It'd be the x of the angle, which would be the cosine of the start angle when we create the bullet. That's weird. And then it should flip it. I might have this backward. Yeah, I have it backwards. I always have it backwards. Oh, no, it just doesn't. It don't care. Maybe it's the sign. No, always goes the same direction. Eh? It's because we're never using. That's why we never use V. I betcha. So, we need to use V here. V.V. And this will probably be add. I wonder, now we'll have to make sure we get 30. Yeah, so it goes that way. How about this one? Yeah, it goes that way. Obviously, this is going to do something stupid, yeah, and we're always setting it to be the same. Because we don't care about the angle yet. But, hey, that's a... I think it's at the bottom of the parabola. That's so silly. Oh, yeah, okay, and apparently it wants to do that now. I think I have completely broken this game. All right. That's not the thing. If we just run it from scratch. Okay. So, you know, we can shoot some stuff. This is not working. Okay, let's look up that gravity equation. That's pretty funny. All my physics teachers are cringing right now. I don't know. Gravity equation. What's this do? That's not what I meant. Nope. Universal gravitation. No, don't want that one either. No. Okay. Let's see. I don't know. Effect of gravity, parabola, formula. There's a word for this. We'll find it soon, I'm sure. Projectile motion. That sounds good. Yeah, look at that. That's what we want. The height of the trajectory. Okay. Should I just start it here? These all look great. Parabolic trajectory. Let's do some research here. Oh yeah, this is even easier. Why didn't I just start with this? Have to try and be clever about everything. So, velocity at 0 is the x component of the velocity plus the y component of the velocity. Yeah. The components v and x and y can be found if we know the initial launch angle, which we know, which is this. Okay, so let's set this up. So we're going to have on our bullets now, they're going to have a Vx and a Vy and a start x. Maybe. No, we probably don't want even the start. I don't know. Okay, let's see here. Don't want the power. Don't care. Don't care about that. We want a Vx equals the cosine. Is it cosine for x? Yes, I was right. Okay, great. Cos of the angle. And the y is the sine of the angle. You can see my super smart autocomplete figuring that out for me. And now we have our initial launch. And then how do they change over time? Kinematic properties. Acceleration. Since there is only acceleration in the vertical direction, the velocity in the horizontal direction is constant. That means Vx is always going to stay the same. Equal to g. The components of acceleration are negative g. So on each, well, it changes linearly, which is good because we're just going to be working with linear time. And the acceleration due to gravity is constant. That means we can literally on every update just affect the y velocity by gravity. So let's just say we have gravity is 0.5. I don't know. We'll make that up and we'll change it as we go. So on each update here, we want to, okay. So the x position, I still need one of those. And I will need a y position. That's fine. Start y. So both the x, the x goes by the vx, and the y goes by the y, and then the y gets affected by gravity. Yes, which pulls down, and that's the velocity that it changes by that. And then that might actually be it, because like the velocity, only the vy changes, vx is constant. And then we need to change this formula, so I don't think we need the function here anymore because we encoded it there. And then to get the y, we don't need that because we just have literally self.x, self.y. And we don't need that, we don't need that. And maybe this will work. Okay, so we're shooting something. Oh, gravity is going the wrong direction. That's the problem. So, gravity. This always catches me. The top of the screen is 0 and the bottom is, you know. Okay, so we need a little bit more power. We're a little bit impotent at the moment. Let's see if we can. Let's just make it so we can adjust that. That's easy enough. So in our update function, we just say, well, we already have button 4 set to fire. So this will be either button 2 or button 3. I don't know which one. We're gonna set the tank.power plus equal 0.1, and alternatively we subtract from the power. And I think when we draw too, we'll probably just want to print out the power, so we'll just do that at the end here. We got our angle and we'll do our power. So we've got a power of 1, and if what's the key repeat on that? I probably don't want these to be button P because you want to be able to hold them down. There we go. So then I can just you can do negative power, and we might want to fix that. Okay, let's keep cranking that up a little bit here. Oof, still a little wimpy. Maybe gravity is just too strong for us. Can I shoot up? Come on. Am I not passing in the power? I bet you I'm not even passing in the power. That's probably what it is when we fire. Where are we firing? Self.power, yeah, that's right. Okay, tank.power. Do we actually use it when we create a bullet? Probably not. New bullet. Power? No, it is completely unused. Okay, so we need to scale these components. So this will be just times power, I think. Times power. Times power. All right, let's try again. Okay, so similarly wimpy at a power level of 1. If we crank it up, we can probably make it move a little quicker. Oh yeah, look at that, power level 10. Can launch it off the map. There we go, this is way better. Woo! For some reason, we can only have 1 bullet at a time. I guess we'll figure that out. What's going on there? We can shoot it off the bottom. If we go negative power, we can probably, yeah. Alrighty. This is coming along now, though. I'll save there. I'm just gonna commit that. This is coming along. Okay. So, what do we do next? I probably want more than 1 bullet at a time. So why does adding to bullets overwrite the previous bullet? That's a good question. Is there like a bullet constant that's not working here? When we fire, we take self.x, we create a new bullet. That bullet here creates a new bullet, yeah. We add that bullet to all of the bullets. Then, yeah, we do the right thing there. Well, oh, here we go. That's silly. Simple, why was that ever, this is one of those, like, why was that ever working, right? Oh man. Lewis got some weird quirks, I tell you. Okay, that should be better. Let's crank up the power. Now I can make it rain. So I guess what's next? Probably won't go too much longer today, maybe another half hour or something. But I think what I want is maybe to, you know, explode on impact with ground or something. That would be nice. So how do we do that? Good question. Let's think. So the one option would be to literally, keep track of like which pixels belong where. But that's kind of hard. So the other option would be just, I think maybe we keep we could just save the topography as an array of y values, and then we can edit them dynamically after we like do explosions and stuff. Let's try that. So I think that's probably gonna work the best. So we're just gonna make our topography explicit, and it's just gonna be an empty array. And then when we initialize, what we actually do here is we're gonna take this function. We're just gonna call this init topography. And then we're just gonna say for each of the i's from 0 to 127, so this should actually be x. Oh, now Lua does not do zero-based indexing, so I guess this will be like 1 to 28 or something. We'll see how that goes. We'll set topography of that x to be the init topography of that x divided, no, it does the 127 division, so that's fine. That's a little weird, but this means we're going to store all of the topography in an explicit array, which means we can actually change it on the fly. This isn't going to work if we end up doing like caves and stuff, but you know, this is just iterative development. You know, we already got like kind of a cool thing happening. Let's keep it rolling. So all of these functions now are kind of different. So rather than this being a function, and now it's just an array lookup, so that should work. Except every time we do the array lookup, it's going to be like, I wonder if we need to do that. I wonder if we can just do this. Let's see if that works. That'd make it a lot easier. Okay. Let's change this. Okay. Good. And same thing here. Does this work? No. Why not? Attempt to perform arithmetic on local y, a nil value, in line 25 in draw. So you say local y is nil because self.x is nil. Now self.x is nil because y. Is it 0? If I refresh, does that work? No. Why is y always 0? On rect fill x minus 2. So it's when I'm drawing the tank. So it's definitely this that's failing. Why is it failing? We're trying to look up self.x, which is random, I believe. Yeah, it is. So for whatever reason, this is not working. I wonder if I'm just missing something critical about how lists work. Let's see. What if I try and set 0 to like 10? Oops. What does that do? Friend? It's a table. Can I look up 0? No? Why not? Can I not index things? I'm confused. What if I print that? That's nil. That's what I'd expect. That's 10, like I'd expect. Why is this not working? Is this not doing the right thing? Yeah, it's returning something. So, as far as I can tell, this is all great. Unless, oh, you know what I bet it is? Yeah, okay. Well, that's a pain. We'll have to build interpolation into this for that to work, because some of these x values are going to be like fractional. For now, I could just like take the ceiling of it or something, but that's not really going to work in the long run. So I'm gonna call this just top, and we're still gonna keep it as its own thing, but then we're gonna bring back the topography function. I guess this is all right. So what we're gonna do here, oh sorry, that should actually be x. Now this is going to look up the ceiling. You know what? I'm gonna pad this because we want at least one extra value on each side, and we are going to say that we're gonna look up in this map. Well, why am I even doing that then? Why don't I just use the, oh yeah, right, so that we can edit it. Okay, so we're gonna take the floor of x as the start, and then we're gonna take the end of end x, or end y, I guess, start y. So we're gonna get the, yeah, seal, oh yeah, but ceiling is not a, oh yeah, it is, okay. So we're gonna get the topography on either side of the x position if it's fractional, and then we're going to interpolate between them. So we're gonna make these locals. So how do we do that? Well, we need to know how far in between them it is. So I think that's just gonna be x minus the floor of x, unless x is a negative number. But that should flip it, which should be fine, I think. So yeah, so that's like the distance in between. So how does this work? So if it's like 1.2, then 1.2 minus 1 gives us 0.2, and that's like the amount that we need to interpolate. So we want 0.8 of the first number plus 0.2 of the next one, because it's actually closer to the first one. Oof, confusing. So, right, then we return start y times the distance, and the distance is always going to be less than 1, which is good. So if it's really close to the first one, so this is 1.2, then it's going to be 0.2, so it's going to be 1 minus the distance plus end y times 1 minus 1 minus the distance, so just the distance. Okay. Or is it negative distance? No, that should be fine. Okay, so that should hopefully interpolate. You'd think I'd know the actual formulas for this. Somebody's screaming in chat, I'm sure. And I have no clue if this works for negative numbers. I don't really care. It should hopefully prevent that error that we were getting. However, I am not actually checking for nils on either of these. So we should do that, because it's going to go off the screen at some point. What happens if, like, how does nil handle this? Nil or 3? What? Can I print? Does it work like Python? Yes, it does. Great. So I can do if not start y or not, or I guess I should really check if they're explicitly nil because they could be 0, equals nil, or end y equals nil, then we do either the start y or the end, I don't really care, or failing that we just return like the topography function, which is init topography of x. This is annoying. This is the like one of the downsides of programming in like Pico 8. It's just kind of annoying bullshit that you have to do that like isn't really super important. Okay, so presumably if we get here neither of them are nil and we can interpolate, and that's fine. So that's wrong. Okay, there we go. So now we have to go back and find all of these topography things, and now we switch them back to brackets. Why not? Yes, and again here. And it'll still crash, but for a different reason, I'm sure. Yep, unclosed if. Okay. Fair enough. Where is the unclosed if? That's the next question. Oops. I mean, we added an if, like, right here. But I do end it, though. Oh, not that one. This one. There we go. Maybe that. Is that the problem? That's the problem. Let's try again. Can I shoot bullets? I can. Can I increase power? Yes. Great. I am amazed that this is working right now. Okay. And we're still drawing everything properly, which I think implies that this is hopefully actually working. Woo! Alright. Another 10 minutes. We'll see if we can, like, erase some topography or something. So we'll say each time that we move the bullet in our update function, now we're going to get back to the fun stuff. Believe you me. Every time we move the bullet, we're just going to check if after we moved it, the bullet y is less than the topography at a given point. Topography of the bullets x. So this should get us like where the land is. And if the, oh no, it's greater than. It's greater than because it's always backwards for y. Okay. So this means that our bullet hit ground and we should like explode it or something. So I don't want to do drawing in our update function because it's not going to show up. So I should probably make like an explosion or something. Maybe I can like change the bullet into an exploding state. Let's try that. Let's just do that. So if it's like that, then we said b dot, okay. And we don't want to move it if it's in that position because we'll want it to stay there and finish its explosion animation. So if it's greater than, then do something else, we move it. So here, this is like, well, no, okay, we can do this better. Trust me. If not bullet exploded. Seems sensible. All right. Otherwise, so since I'm doing both, I'll just do if bullet exploded. Otherwise, do that. All right. And then we just say if after moving we should explode, then we explode. And it's okay if that triggers because it's idempotent. So now when we are exploding, well, let's start off with the simplest case. We can do nothing. And then draw it. So let's draw our bullet. And when we draw a bullet, we'll say if, well, the X and the Y are always going to be the same, but we won't, oh, that's the tank. Where's the bullet draw? Oops, bullet draw. Here we go. Yeah, so this is very easy. So if self.exploded, then, okay, where am I making the new one? Let's explicitly say that we start without an exploded bullet, because otherwise that would be bad. Then, when we are exploded, we will. Is this, is it a real Pico 8 stream if you don't use the Pico code editor? I would say yes, because otherwise we would have maybe drawn one thing on screen at this point. So I don't know. I'm definitely not a purist. But I do use Vim, so it's a lo-fi editor, I guess. We'll go with that. So if we have exploded, then we draw a circle. Otherwise, we draw the pixel. So let's do a circ fill of red at the same position with a radius of like 5. That should be nice. Who knows if this is going to work? So presumably we're going to shoot a thing. When it hits the ground, then it explodes, and it'll just stay exploding forever and ever and ever. Okay, good bullet. Boom. Okay, and if we crank up our, can we shoot it? Boom. Ha 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 ha. Love it. Pew. This is kind of fun. All right, let's get these animations working. And then what we can do is we can, now that we're tracking the land properly, we can erase the land where it explodes. I also notice we have like a little bit of a problem here where if the bullets are going too fast, they could like kind of go through the ground. So that's a royal pain to fix, but we can do it at some point. You know, we can do better collision detection. Whee! Yeah, because you can see these explosions are like going into the ground. Maybe that's part of the charm of the game. We can just say that. But I like how that's going. So now we probably want to like fade those explosions over time, or like make them look pretty. Let's make them prettier. So if we do like, we could probably also scale, well, we'll probably scale the explosion by the type of bullet later on. But let's draw different circles with different colors and see how that works. Yeah, that looks like an explosion. Look, I made an explosion. Boom. We're gonna increase this one to 4 and 3 and try that. Great. Okay, and then they will fade after a little bit. We'll probably add sound effects and stuff like that. But so we're gonna change exploded to be a number. Just because. If exploded is greater than 0. And we're gonna set exploded to 1. So now we can keep track of the animation state in the explosion. The other alternative would be to just delete the bullet and like add an explosion object, which would probably be smarter, but we're just trying to get things done. So when we draw it, we can check the exploded state. So if it's 1, we do this. Else if self.exploded equals 2, now why is this complaining? Did I miss something? Do that. Otherwise, else if self-explode. Oh, I need another then. That's all. Okay. Then we do this. Else we do that. So after we've exploded for a little bit, we're gonna like take it down a notch and maybe color it with like gray, because it's gonna be like smoky, right? I'm not terribly good at animating these sorts of things. I could probably do something if I spent a lot of time on it. Or we're gonna try this, and we're gonna try p-fill, or piece, is it p-set? P-set? No, that's pixel set. That's a fill p, it's fill p, fill pattern. And I'm going to set a fill pattern that's like kind of patchy. It's like a checkerboard pattern. We'll probably change it so that when we draw this type of explosion, it'll be like kind of patchy. And then eventually it will, I guess, dissipate. So when we update the bullet, if exploded is greater than 0, then let's say if we don't want it to, well, let's just see what happens. So let's just set b.exploded plus equals 1. And we'll also say if b.exploded is actually greater than like 3 or something, then we can delete it. Delete b from bullets. And it will go away forever. And it did nothing. So so we're setting b.exploded to be 1, and then we're incrementing it. Are we never deleting it? Why is this not triggering? Oh, because this is always resetting it to 1. Right. What if I do b.exploded or 1? Okay, that's a dirty hack, but it should work. No. Nope. I guess. Does it count 0 as a 0 or 1? Print 0 or 1. Yeah, 0 is truthy. I knew. That's annoying. Okay. Let's just do and b.exploded equals 0. Oops, there we go. Okay. So you can see they do explode now. We probably want to add like an additional frame or something. That's pretty cool though. I like that. So let's expand these frames. So let's say for like, rather than doing that, what we're gonna do is do kind of a range. So we're gonna say if it's 0, then we draw this. Otherwise, if it's less than 2, we're drawing that. And if it's less than like 5, we'll draw that. Actually, we could probably just do an else here. Otherwise, we draw that one. Kill that. Then we just need to update our deletion logic so that we don't delete it until we hit like 5 or 6. And then we should get like a nicer unclosed function at line 55. I find these line numbers are not exactly correct, which is kind of annoying, but it's probably my own. Oh yeah, I'm probably just missing an end or something. Oh no. Is that just a glitch? Or did I? Nope, definitely broke something. Oh, it's probably just drawing it funny. Okay. If self.exploded. Oh, and then this is else. If not, just else. Oh, see, and then now I have too many of these. Well, that's better. Okay. So you can see kind of it does like the little explosion. We could probably set it to be like transparent on black or something, and then they do something cool. That's fun. Let's make another commit there. Explosions, right? All right, we're almost done for today. So I've said that like 3 times. I just really want to get like this, the Earth destructing, I guess. How can I do that? So in the original game, it would like chop out a bunch of pixels and then like drop the remaining pixels. We probably won't get that animation stuff working quite today, but I can probably, well, no, that's not going to be easy either. Maybe we'll call it there. I'm slowing down. We got a fun little game. We can't shoot anybody, but we can, you know, we can set our power, and collision detection is mostly working. Whee! I'm pretty happy with that. Boom. Sweet. Well, thanks for tuning in. Yeah, I'll probably do more of these. I'd like to polish up a few of the games that I'm making on here. So, Insane Aquarium and Scorched Earth, and actually get them workable. Cheers, everyone.